Today I will cover the last EBQ model, that is the manufacturing model with shortage. Here in this model I am drawing the figure we know that manufacturing model means in this the sub part that is required for the main product is manufactured within the plant itself. Q1, this is Q1, this is Q2 is up to this point, Q1 is up to this point, and the total is, let's say it is Q1 plus Q2 is our units optimum quantity EBQ, that is Q. Let's say this point is A, this point I am giving as O, A, and this point I am giving the letter as B, this point I am giving as letter C, and this point as letter D. And different time zones are this is T1, this is T2, K minus R, this is R, T3, T4, starts. So now I'll start explaining this inventory at this point inventory is 0. We can see that it is at 0 point, inventory is 0, and it increases at a constant rate of K minus R for the time T1, and it is maximum here, inventory is maximum here, maximum inventory. R is the annual rate of in the previous model I have already told you that in R is the annual rate of consumption, where K is the production rate of the items, and as there is no replenishment during the time T2, we can see that inventory, there is no production, only consumption. So inventory decreases at a constant rate of R until it becomes 0 again. Here at this point inventory is 0, at this point inventory was 0, at this point inventory was 0. Here it is building at a rate of K minus R and reaches the maximum point A. After that only consumption takes place, there is no manufacturing, there is no production. Again now there is a shortage starts into picture. That means we have the demand but we could not able to fulfill it. So its shortage starts at the rate of R, that is the consumption rate during the time period T2, T3. This is T3, and at this point of time again production starts, and the backlog that is filled at a constant rate of K minus R, production rate is K and consumption rate is R. So total at a constant rate of K minus R, then it is satisfied until it reaches the point D, where again inventory is 0, and this occurs during the time period of T4. So total time, so from this figure we can see that total time T is equal to T1 plus T2 plus T3 plus T4. This is our total time, and all other parameters remain same as I have taken for the manufacturing model without shortage, like CC is the carrying cost per unit, and CO is the cost per setup, and R is the annual demand of consumption of an item. Let's say R, annual demand of consumption of an item, and K is the production rate of an item, production rate of an item. CO, here CO, usually we have given CO a symbol as for the ordering cost per order, but here we don't give any order, we are manufacturing the part within the plant itself, but we have to give the cost for setup of machines which is required for the production of that sub part, so that comes under as ordering cost, CO. So this is that is the CO, that is the cost per setup, it's not ordering cost, it is the cost per setup, but symbol I am giving as CO only. Then CC, we know CC is the carrying cost per unit per period, carrying cost per unit per period, maybe year, usually we used to take year if nothing is mentioned, and P is the cost of production per unit, P is the cost of production per unit. T1 is the time at which inventory is built at the rate of K minus R. T2, time at which inventory is consumed at the rate of R. Then T3, time at which shortage is built at the rate of R, and T4, time at which shortage is filled at the rate of K minus of R. So these are the different time periods. Now first we will determine the total cost, and which consists of all the cost, setup cost during T is during the cycle time, that is T is equal to C0 R by Q. We know that in case of purchase model we use C0 D by Q. Here instead of D it is your R by Q. R is the annual demand of consumption, and Q is the total quantity manufactured, which will give the into the number of parts. So as CO is the cost, as we can see that CO is the cost per setup. For one setup cost it costs your CO, for R by Q setup its total cost is C0 R by Q. Then carrying cost, during time T is equal to carrying cost is CC. Carrying cost is the carrying cost per unit per period. For 1 unit it is this much multiplied by, and we can see that carrying cost is the carrying cost of inventory, and we know that for this triangle, this zone only up to the period T1 only we have the inventory. So inventory is being carried away. It is triangle OAB, and here also inventory is there, but it is reduced. It is being reduced, but inventory is there until it reaches again 0 point. So area of triangle OAB will give the total inventory. So total inventory into the inventory carrying cost per unit. So total inventory quantity is given by triangle OAB. So it is CC into half of AB, half of base into height. You can see that base is your T1 plus T2, height is the maximum inventory. That is, what is this height? This height is our Q1. So half of T1 plus T2 into height Q1. Then third one is your shortage cost during T. Is equal to shortage cost per unit is our CS, and we can see that this triangle shows our shortage cost, triangle BCD. So this triangle is for shortage cost, and this triangle is for inventory carrying cost, triangle BCD into triangle BCD is equal to CS into half of BCD. This base is our T3 plus T4, and height is our Q2. We can see this height is our Q2, and it is T3 plus T4. So this is equation number 3. So this is equation number 2, and here this is equation number 3. So we got the 3 costs, and we know that total cost per unit is the summation of total cost will be the summation of 1, 2, 3, and if we take the average total cost per unit time, so all these costs will be divided by the total cycle time. So let's say average total cost per unit time is equal to CO into R by Q plus CC Q by 2 T1 plus T2 plus CS Q2 by 2 T3 plus T4 divided by cycle time is capital T, which is equal to small t, that is the total time T1 plus T2 plus T3 plus T4. This is our cycle time. So this is the average total cost. Now Q1, we know that Q1 is equal to Q1 is a rate, Q1 that is the maximum inventory is equal to K and rate of consumption into the time T1. Rate of consumption rate is our K minus R because here the inventory increases at a constant rate of k minus r. It is k minus rate at which the inventory is created into time t1. Also q1 is equal to r times of t2. Rate of r is the rate of consumption. This q1 is equal to also r into t2. q1 is equal to k minus r into t1. It is also equal to r into t2. So therefore k minus r into t1 is equal to r times of t2. Make it as, let's say, equation number 4. Similarly, q2 is equal to r times of t3 is equal to k minus of r times of t4 is equal to 5. Then adding equation 4 and 5, add equation 4 plus equation 5, we get k minus r t1 into t1 plus t4 is equal to r t2 plus t3. So it is very clear. K minus r, let me make it very nearby. K minus r k minus r t1 plus t4 is equal to r t2 plus t3. So this term we got it. Now again manufacturing quantity Q. So let it keep it in a box. Again manufacturing quantity Q. This EBQ we want to find out. This Q is equal to manufacturing rate into manufacturing time. So manufacturing rate, we know that it is KT1. We can it is though it is consumed it at the rate of inventory we are having at the rate of K minus R, but K is the manufacturing rate, and it is manufactured in the during the zone T1, and it is also manufactured during the session T4. So K, so manufacturing rate, it is equal to your manufacturing rate is your KT1 plus KT2. So that is, it is equal to T4 at T1 plus T4 at time T4 and T1 also only it is manufactured. Rest T2 and T3 it is consumed. So it gives T1 plus T4 is equal to Q by K, because it is a manufacturing time. This is the total manufacturing time. T1 plus T4 is the total manufacturing time. It is Q by K. So Q1 plus Q2 we have already determined from this is equal to we can see Q1 plus Q2 is equal to Q1 plus Q2 is equal to R times of T2 plus T3. Here we can see these things we have derived. We can see that Q is equal to Q2 is equal to RT3 and Q1 is equal to R times of T2. From these two equations, Q1, if we add it up, Q1 plus Q2 is equal to R times of T2 plus T3, and T2 plus T3 it is equal to now K minus R. It is also equal to K minus R T1 plus T4. We can see RT3 is equal to K minus RT4 and RT2 is equal to K minus RT1. So from these two equations also we got RK minus RT1 plus T4. So we have completed all the T2 and T3 also in terms of T1 and T4. Why we have completed? So it will be equal to now K minus R. So as we have converted T2 and T3 in terms of T1 and T4, but as we got T1 T1 plus T4 is equal to Q by K. Now just we put it. Now, so this is the first equation, we will be determining it. Q1 star is equal to Q K minus R by K. This one minus of Q2. So we will make it in a box. Once we have the economic batch quantity, we know the Q2, we can directly put the formula and get the result, get the maximum inventory, that is Q1 star directly. Then second, T1 plus T2. T1 plus T2, we can see that T1 is equal to Q1 by K minus R. Q1 by K minus R. Similarly, T2 is equal to Q1 by R. So ultimately, if we just sort it out, we will get, and Q1 value we can put, just now we have determined the value of Q1. If we put this value over here, so we will get Q K minus R by K minus Q2 1 by K minus R plus 1 by R. So I have just put the values. Now T3 plus T4, T3 plus T4 is equal to Q2 by R plus Q2 by K minus of R. So if we take Q2 common, it will be 1 by R plus 1 by K minus R. We are putting so that these two terms are common. So total time T1 plus T2 plus T3 plus T4 is equal to T is equal to, if we add it up all, we sort it out everything else. If we just add it up all these two equations and put the values, we will get Q by R. So this is the cycle time, total cycle time, optimum cycle time. So that's why I am giving this star symbol. This is the optimum cycle time. Now we have to determine the optimum Q. Till now we have not determined the formula for optimum Q. Total cost is equal to Cc Q1 by 2 T1 plus T2 plus Cs Q2 by 2 T3 plus T4 plus C0 into R by Q. We know that total cost, this is the formula for total cost, average total cost divided by T. So then T, the value of T is equal to Q by R. If we take this T to the above, so it will be R by Q. Instead of T we have put 1 by T value is R by Q. R by Q we have put it. Then Cc by 2 Q K minus R by K minus Q2 Q K minus R by K. I am putting all the values that I have derived just now into 1 by K minus R plus 1 by R. So this is for the first term, that for this term up to this much over. Now I will start putting the values for the second term. Plus Cs by 2 Q2 1 by R plus 1 by K minus R plus R by Q dot CO. So this is the total cost we have put it. If we just simplify it, we'll try to simplify as much as possible. R by Q we got it 1 by 2, where I'm taking common 1 by K minus R plus 1 by R. Then we go, this is the common I'm taking it. Then remaining is Cc Q K minus R by K minus Q2 square plus Cs Q2 square plus R by Q CO R by 2Q K by R K minus R into Q K minus R by K minus Q2 square plus Cs Q2 square plus R CO by Q is equal to K by 2Q Cc K minus R by K minus Q2. So this is the common we got it, plus remaining is Cs Q2 square plus R, just I'm putting it like this. Let it be equation number 6. Now there are we can see that two unknown, that is Q2 and Q. In this equation we can see this is Q is there and Q2 is there, so we have to take derivative each one by one. Let's say first we take the derivative with respect to Q2. Just now I have rearranged the terms. Now we will start taking derivative. That implies 1 by 2Q into K by K minus of R 2 Cc Q K minus of R by K, I'm taking the derivative, minus Q2 into minus 1 plus 2 Cs Q2 is equal to 0. That implies 2 Cc Q K minus R by K minus Q2 is equal to 2 CS Q2. To Cc Q K minus R by K minus 2 Cc Q2 is equal to 2 Cs Q2. So that employs 2 Cc Q K minus R is equal to, twice we take common, Cc plus Cs into Q2. This divided by K I have not written. So ultimately, so formula we are getting, so that implies, now we got the formula for Q2. Q2 is equal to Cc by Cc plus Cs into Q K minus R divided by K. But again in this equation also we are getting Q2 in terms of Q is there. Till now we are having the Q, so we have to remove this Q. So let's say we keep this equation as equation 7. So now we take the derivative with derivative of equation 6 with respect to Q2. Derivative of equation 6 with respect to Q. Now we got that implies 1 by 2 Q square into K by K minus R Cc Q K minus R by K minus Q2 square plus Cs Q2 square plus 1 by 2Q K by K minus of R and 2 Cc Q K minus R by K minus Q2 K minus of R divided by K minus R CO by Q square is equal to 0. Now I have taken the first derivative on, if you simplify it, you will get on simplification gives Q star. So ultimately we got the economic batch quantity, this is EBQ, Q star is equal to twice of C0 Cc plus Cs divided by Cc dot Cs into square root of K dot R divided by K minus R. So this is our Q star. So ultimately we got this Q is square root of 2C0 by Cc into this much. Instead of, we can write a common root also. So it is, so this is the formula for Q star or EBQ. EBQ when it is a manufacturing model with shortage. This is the main formula. And we know that now Q2, we have already have the Q2 this much. We can put the value of Q in equation 7, so that putting the value of Q star, putting the value of Q in equation 7, we get Q2 star is equal to 2 C0 by Cc into Cs by Cc plus Cs into r k minus r divided by k square root. So this is for q2 star. So now we got q2 star. This is the main formula, and q1 star we have already derived q1 star. This is q1 star. q1 star, you got q, you have derived q, you have derived q2, and q1 star is just this much. And t, you have got it, t is equal to q by r, and t1, and from here you can get t1. Okay, and t1 we know. Okay, let me write down all the t's. Then t1 is equal to, now I am giving star because it is the optimum quantity. It is equal to q1 star divided by k minus r. T2 star, it is equal to q1 star divided by r, consumption rate. T3 is equal to q2 star divided by r, and T4 is equal to q2 star divided by k minus r. From the figure you can very well know it. So these are the all times, different times which will correspond to the cycle time. So in this way, this completes your EOQ model.